All right. Let's see. I put in an About Me slide. Usually I don't do that, but I found out there's so many new people who haven't seen me before that I thought, well, just put one in. I'm working for Airbus Cybersecurity, Airbus in being the company that is the European counterpart of Boeing. So we're making aircrafts and all that stuff. I'm doing network analysis like for a long time, 2003. If I would be going into net X-ray, that would be 1996 probably even, but that doesn't really count because I was clicking on stuff and not knowing what I was doing. So let's say I started in 2003. It was mostly Sniffer Pro, Sniffer Distributed, and later ClearSight, which probably nobody ever heard of, maybe, I don't know, a couple of people. And then, of course, I got into Ethereal or Serial or however it's pronounced. So I also do a couple of things besides working with Wireshark, and that is, first of all, I have written a small program that is called Tracewrangling, and I'm writing a blog post at blog.packetfoo.com. The blog posts are really slow, so I do not a lot of them, because I want to make them almost like a reference kind of thing, so that you can read up on stuff that is as precise as possible. That's because I'm German. And every once in a while, I will post something new. But today, this is going to be about Tracewrangling. And we will talk about file and task concepts, about editing, anonymizing, extracting packets, and I will do a couple of live things to show you what it can do. The biggest problem with programming a tool yourself is that you don't really have time, or you don't want to write documentation, which means you're the only guy who knows what it can do. So I'm probably going to show you a couple of things that is nowhere documented, and yeah, I know I have to, but I'm slow. Okay, so Tracewrangling is a trace file or sniffer capture or whatever you call your packet dumps manipulation tool. It started out as a sanitization anonymization tool. That is something that most of our presenters need, because you have something very cool, but it got something in there where the customer says, oh no, you don't. So we need to sanitize the stuff so that we can use it. And I also had occurrences where I was in a company and there was a firewall administrator that said, well, our checkpoint is not behaving correctly, I think. And they want us to send them traces, but there's our internal IPs in there and other stuff. What do I do? Well, if it's a TCP problem, you could just sanitize it and replace all the IP addresses and that kind of stuff. Cut away everything on top of TCP, because usually a firewall doesn't care about that thing anyway, and then send it. So anonymization is important for a lot of people, but my biggest fans usually are the presenters, because when SharkFest comes up, usually I get bug reports, like in the night before it starts. Hey, this doesn't work, can you take a look? I'm presenting tomorrow. I'm like, guys, come on, 2 weeks please, or 4, or whatever. Okay, then another thing happened. I was showing this one, I think for the first time at SharkFest 2013, I think it was. And then somebody came up to me and said, well, I have this crazy Juniper device. And this Juniper device adds something in front of the Ethernet header. And that leads to no tool being able to read that damn thing except Wireshark. So can you remove it? And then I started adding editing tasks, which allows you to remove stuff like VLAN tags, GRE tunnels, GPRS tunneling, so that you get a plain Ethernet, IP, TCP, whatever kind of thing. And it runs with most tools that don't expect that fancy stuff. VXLAN, I think, is in there already. So I will show you that one too. Then a very big thing came up, because I don't know about you, but my usual size of trace files is not in the megabytes. It's usually in the gigabytes, sometimes terabytes. And that is a problem, because if you try to load a terabyte into Wireshark, no matter what machine you have, you don't want to. Because even if you got the crazy machine from hell with a terabyte of RAM or whatever it is, every time you apply a filter, it will reread all the packets from disk because, little known fact, Wireshark doesn't keep packets in memory. It only keeps the one in memory that you currently see in the decode pane. Everything else stays on disk. So if you apply a filter and you wonder why it takes so long, it's rereading the whole file every time to see, does this packet match? Yes. Does this packet match? No. Does this packet match? Yes. And it does that every time you filter, which is why when Christian said, use the find function, that is a good tip. The bigger the files get, the better you are with the find function because it doesn't apply filters. So it's no rereading all the time. And you can jump through packets without having to wait all the time. But if you get big packets, big traces, big capture files, you need to extract the stuff that you want to see because, as most Wireshark developers will tell you, Wireshark is like a microscope. It's not expecting to see tons of millions of packets, but it's there for inspection on the smallest level, like a little glass tray with a dot on it, and then check things out. But to get there, you need to get there somehow. Yeah? Christian very often does that with T-Shark scripting, and there's a little competition between me and him that whenever I have something where I think I can do it in a real cool way, he's like, you don't need to, I can T-Shark this for you. And then we try to find out who can do it better, me or him. Sometimes I win, sometimes I lose, because if my development time is longer than him doing his T-Shark stuff, not a good idea, okay? So I will show you a couple of things like that. And then there's merging, which I removed from the demos because it's not interesting anymore, or not that much interesting anymore. There was a time when Wireshark was not so good at merging captures with multiple capture interfaces. As you probably know, you can capture on multiple network cards at the same time, and if you try to merge them, that got problematic at some point. But MergeCap got a lot better now, so just use MergeCap, okay? If you want to, you can still use Tracewrangling for this, but you don't have to. Okay, so the question always is, what's the difference between Wireshark and Tracewrangling? And first of all, it's the number of protocols that we understand. Wireshark wins easily because it has like, I forgot the number Gerald used this morning, but it was a lot. And I have 34. The reason for that is I write all the dissectors, or I call them parsers myself, and my time doesn't scale, so it takes a while. And I run into problems sometimes. I have to bug fix them, so it's really slow doing that. Tracewrangler doesn't do protocol decodes. It will not show you a decode pane and then flags and stuff like this ever, because I'm not trying to replace Wireshark. That doesn't make any kind of sense, because Wireshark does that much better than I ever could. My tool is just doing the parsing to be able to pull things apart and put them back together and give you extracts and stuff like this, but not for display purposes. So I always wanted to have a tool that is capable of opening more than one file or processing more than one file, because very often you do a capture for a long time and you don't want to have a 4 terabyte file in the end, but you do 128 megabyte files, like thousands of them. So the latest job I had was, I think, 5,000 files, 128 megabytes each. And if I want to process them as one, my tool needs to be able to work with a file list instead of just one single file. Otherwise, it's not really useful. So that's what it does. It can hold hundreds or thousands of files, and the biggest thing I process with this in one go is 600 gigabytes. Yeah, so that is something where it takes a while, but it works. And very often we do stuff like set up an extraction task overnight, go to bed, get up, check the results. And if Christian does it and Tracewrangler crashed overnight, I'm blamed, of course. Like, hey, you wasted a whole night of, yeah, sorry, it happens. Okay, so filtering is in Tracewrangler, but only very basic, because usually I only need this to find TCP conversations again. And I don't have 100,000 display filters, because I'm not displaying anything anyway, so it's more like a BPF thing, and even that is reduced. The funny thing is that I can show you a conversation statistics of all the files that are currently in the file list, not just the one like in Wireshark. So you can add like 600 gigabytes into Tracewrangler, open the conversation statistics, and you get one for everything. And the cool thing about that is that it will show you each conversation only once. So if it starts in the first file and ends in the 10th, you only get a full line for that conversation over all the files. And then you can extract that kind of thing. OK, packet manipulation. I think we don't have that anymore in Qt. We used to have it in GTK, and it was experimental. So few people know this, but it was possible to edit packets in Wireshark in GTK. This feature hasn't made it yet into Qt. So if many people complain about this, maybe they will do it. But I think there's other solutions that don't make this a requirement anymore. Good. So I have this file list. As you can see, the file list contains, in this case, I don't know, 20 files. It says here, 20 files. Total frames, 7 million, 7.8 million. Total bytes, 5 gigabytes. So this is a set that it's going to work on. And then you can add tasks here and work on the files. So adding files, very simple, drag and drop, add button, pop-up menu, whatever. I will show you. The one thing that Tracewrangler does is it indexes the PCAP files. This means it runs through all the PCAP files and pulls out all the IP addresses it sees, all the conversation it sees, all the UDP stuff it sees, tons of things. And the reason for that is that capture files, when they're written to disk and complete, they usually do not change anymore. So as soon as I've scanned them, I know what's happening in them. I know which conversations are in them. I know where the first and last packet of each conversation is. And that helps a lot by speeding up things, because if you know that, you can stop reading when you know there's no more packet that can have this criteria. So that database is quite useful. And it only scans it once. So when I add them the first time, they will be scanned. And afterwards, they will just be reread from the database. And I know everything. And that is really helpful, because I can give you helping features like, hey, this IP address doesn't even exist in the files that you have currently in your file list, because I know it's not in there, or I know it is in there. So you don't waste time on filtering on stuff that's not even in the files, because that happens a lot. So this is how it looks like. It's just an SQLite database where it's written to. This can take a while, so sometimes the scan has to run for an hour or two, depending on how many files you throw at it. I wrote a small command line tool that is faster, which I use now. What it does, it scans all the files, writes database for each file, and then merges them into one big one. So that is a lot faster than writing it for each file every time. And, well, then we need to add tasks. And this is basically something that I will be showing in a demo real soon. Because staring at slides is not very interesting. So first of all, I need to talk about anonymization tasks. And that is something, as I already said, that I started with because I needed it. Whoever anonymized a trace file by hand with an hex editor, or with Bitwisty, or with TCP rewrite, knows how much fun it is. It's like going to the dentist with no kind of pain thing that they do to keep you away from it. No worries, just answer it and say hi from me. Good. So I was in so much pain because I was replacing IP addresses for talk once, and I had to rerun the anonymization command line tool, I think, a dozen times to replace all the IP addresses, because you could only replace one pair per run. So we're doing stuff like replace this into this file, then take this file, replace that into the next file. So you're creating new files all the time, and that is just a waste of time. What I want is drop a file on there, say, please remove all the nasty stuff, go, thank you. The problem with that kind of thing is you need somebody who knows what's nasty and what's not nasty. So you need somebody who's a network analyst who knows what is critical, what is not critical. And for that, I need to program it myself, because programmers usually often don't know what packet captures are. They don't know what is critical. They don't know what an IP address is that is a private one or a public one. So that ended up with me writing this tool. So I started Tracewrangler to anonymize stuff. And since I'm not a programmer, and I don't know any cool programming languages, I wrote it in Delphi, which means that nobody except me can write it, because only me and Russians know Delphi. And that's also the reason why it only runs on Windows and on Wine if you use it to run the Windows binary on Linux. So I apologize for that. I will try to make it cross-platform whenever possible, but so far, no luck. OK, so changing things in a capture file usually means IP addresses, MAC addresses, application payloads, very critical. And what I do is I have a preset. So I'm presetting some options to the best of my knowledge, where I think if you run your trace through it, whatever comes out is not critical anymore. Yeah? So I'm removing basically everything that could be in any way critical. If you want to keep stuff, you can do that. You can uncheck some options and change them and add more options, whatever you want, but you need to know what you're doing. If you don't know what you're doing, just add your files, run it with the default set, and it's usually good. I also wrote a blog post about this, so if you want to read up on it, it's on my blog. So sanitization is a 4-step process. First of all, you need to parse each packet. You need to find all the protocol layers, and that means you need to understand them all. And as soon as you hit a protocol layer that you don't understand, usually that is after TCP. So very often what you understand is Ethernet, IP, TCP, and then it's like, this could be anything. Because what runs on top of TCP is based on port numbers, and if you see port number 80, what is the protocol on top of that? No, you don't know. It could be HTTP, but it could be anything. Yeah? So assuming that it's HTTP is quite valid in 99 point whatever %, but it could be anything else. So assuming that it's HTTP can be dangerous. So you can't really do it. What I'm doing in Tracewrangler is if I get a port number that tells me, hey, this is UDP 53, then I'm assuming it's DNS. So I start my DNS parser and say, can you quickly check if this is really DNS before you do something crazy? And then we'll check a couple of bytes in there and say, yeah, this looks like a query or like an answer or whatever. And then say, yeah, it's plausible or not plausible. If it's not plausible, it will be considered an unknown payload and removed. Yeah, so that's how this works. In other programs, that is sometimes called port-independent protocol identification, PyPy or PP or whatever you want to call it. So that is like an art form in itself, detecting the protocol that is running on top of TCP or UDP, because it could be anything. All right, so if I know what I got, if I have parsed all my layers and I found the one that I don't know anymore, then I extract all the values. So I pull everything out and discard the packet. I don't keep it, because a lot of people assume that if you're anonymizing packets, you're patching stuff into it. Yeah? Most people probably think like, hey, if I need to replace an IP address, just patch the bytes over the existing bytes. That is not a good idea, because IP addresses can exist in so many places that you don't expect. What do you think? Where you can find an IP address? Well, in the IP layer. But it could also be in the TCP layer. Have you ever seen an IP address in the TCP layer? Because I have. Pardon? HTTP. Yeah, that is a special case because the HTTP header contains the IP address sometimes in ASCII form. So that is even more special. But I have seen IP addresses in TCP options. For example, Citrix uses that sometimes to tell you some IP address in the TCP header. And if you don't expect that thing, it will be exposed. So I wrote Tracewrangler in a way that it parses everything. And if it finds this Citrix option and it doesn't know how it's working, what it's like, how it's to be parsed, it just ignores it and drops it. So no exposure of critical stuff that way. So if you have all the values, then you need to do the next thing. You need to rebuild the packets after you changed all the values. So if I have IP addresses, I have a database, and I tell the database, hey, I got an IP address, give me the replacement for this. And then my database will check, is there this IP address already in my database with a replacement IP address? So do I have a pair? If not, create a new one, write it into the database. And that makes sure that whenever I ask for the same original IP address again, I get the same replacement again. Because that's the other problem of anonymization. If I replace an IP address with random stuff, all the IP addresses will be completely different. And then you cannot do an analysis on it anymore because everything just goes to hell. So you need to keep it consistent, which means you need to track, I'm replacing this with this. And that needs to be consistent across the layers as well. So IPv6 is a funny example because in IPv6 you have IP addresses that are based on MAC addresses. So if you're replacing a MAC address with another MAC address, that means you also need to replace the IPv6 address that is based on that MAC address with the replacement MAC address. That is step one for that kind of thing, because then you have the solicited node multicast address that is based on the IPv6 address, and you also need to change that one. So that was actually a funny afternoon for me, because I was thinking, hey, I do a quick change in Tracewrangler for IPv6, because IPv6 has one very, very cool feature. There's no subnet masks anymore. So if you get an IP address where the prefix is the same as for another IP address, you know they're from the same network. Yeah, if the prefix is the same, those two IP addresses are in the same network. And then I can put them in the same replacement network. So it's extra cool because they stay together. Easy change, right? I thought, well, it's maybe an hour of work on this. And then I found out about the MAC addresses and the solicited node multicast, and then a full weekend was gone. Because that's what happens. Okay, so you build a new packet and you write it back to disk. So in fact, you're building a whole TCP IP stack, so to speak, pulling stuff apart, interpreting stuff, changing stuff, putting it back together, and doing the output. That's exactly what a TCP stack does. A very simple one, of course. Okay, so the most important fact is everything that is not understood will not make it into the constructed packet. So you cannot expose anything that you don't know about by mistake. That is very important. I had one discussion with a guy who said, well, Tracewrangling is quite cool. I'm building a web service. You can upload your PCAPs, and I will give you a sanitized version. Like, you really think somebody will upload their critical PCAPs to your web service? I don't think so. Because that would mean they would give you their to-be sanitized PCAP without being sanitized yet. That doesn't work. And he insisted, like, they will do this, it's cool. And I'm like, yeah, what happens if somebody exposes stuff with your web service? And they will sue you for it because you're the one who's responsible for doing the sanitization. Do you really want to do this? Maybe not. He was American, so when you come up with suing somebody, they're like, no, let's not do this. Okay. Good. So I have 24 protocols. I've got the most important ones like Ethernet, ICMP, IPv4, IPv6. I got MPLS, NetFlow, not that important, but anyway, TCP, UDP, and some other stuff. VXLAN is only in there because it's so simple. It's like the most simple protocol ever. So I think right now it's my template for building new dissectors because it's so simple. It's just a couple of lines of code. So the most important checkbox if you're configuring your anonymization feature is this one. And that is remove all unknown layers and cut away the bytes, or whatever you want to do with them. But this checkbox needs to be set, because if you remove this checkbox, Tracewrangler will keep unknown stuff. And that means you may be exposing stuff that you don't want to expose. I only recommend doing this if you have a trace where you know that you only want to change maybe the IP addresses or the MAC addresses or something on the lower levels, and you want to keep your HTTPS payload because it's encrypted anyway, then you can do it. Okay? But otherwise, this checkbox needs to be set because you never know what happens otherwise. Okay, so let's demo this one. By the way, if you want to get it, I built a new version 2 or 3 days ago, which is always dangerous because I'm using this right now for the demonstration. As Jared says, let's try something stupid and dangerous. So this is my web page for the tool. Oh, it's gone. Why is it gone? Huh. No signal. Help. I didn't do anything. Ah, there it is. Whatever happened. This is the website. As you can see, I'm not a web developer either. Also not a designer or whatever. But it's fast. So you can download stuff real fast. There are 32-bit and 64-bit versions that you can download. I always recommend the 64-bit version because seriously, who's still running 32 bits? I hope not so many. But if you need to, well, there's one version. The reason for 64-bit is if you run a couple of 100 gigabytes into Tracewrangler, it will take some RAM to do that. And 32 bits runs out of memory quite fast. So the biggest thing I had on my machine, I have 64 gigabytes at home, was I think close to 48 gigabytes of memory used for the 600 gigabytes of PCAP files. One special tip for all of you who are here. This here are the official versions. There's also the source code. So if you want to learn Delphi, go ahead, download it. And the most important thing is there's a semi-automated build section. It's semi-automatic because I have to trigger it manually. But in there usually is the latest version. So sometimes I don't dare to put out a stable version. It's not that stable because it still crashes every once in a while. But the semi-automatic ones are much more up-to-date. But sometimes there's something in there that still is not working correctly. So use with care, but I usually prefer if you downloaded the semi-automatic ones. And I will be replacing the static ones with the automatic ones in the future because most people should use the latest version anyway, because usually there are more bug fixes in there. Okay, so this is how it looks like. Very simple. Let's do some traces. Let's start with anonymization. Real simple example. I have a HTTP example. Looks like this. I should probably change my profile. So just GET requests and answer, simple stuff, right? So I don't need to run gigabytes of trace files just for a demo. So I just want to show you how this one works. So you can see that there is 192, 168, 124, 100. That is my workstation at home. 81, 209, 179, 69 is one of my web servers in the data center. It's one standing right next to the block server that Lundy was using in his presentation. That was a .74. So I use that one, and what I usually do, because I'm really lazy, is I don't use the Add Files button, because then it opens another requester and stuff like this, so I just drag and drop the stuff. And what Tracewrangling will do, it will read the first couple of bytes and determine the file type. So it will see, oh, this is picabenjy, and then add it. You can drag anything on it, but if it's not a valid capture file type, it will notice, and it will not let you add the file. So I could try, for example, I don't know, let's try this one. So it doesn't appear, because it's not a capture file. Right now I can read picabenjy, .enc, which is the very old sniffer format, and .cap, which is the old, not that old, but old sniffer format. Historic reasons, because I still had sniffer capture machines at home. One of the ideas is to add the ERF format used by NDACE in the future, or ELF, I can't remember what it was exactly. Just the current formats should be supported. So we want to anonymize something, so let's just say anonymization. As you can see, you can anonymize quite a lot, so the most important thing is set. You can decide what you want to do with the unknown layers, like remove the bytes completely or replace them with zeros. This is a fun thing very often, because if you're doing a training where you want to hurt your students with big trace files, cutting away bytes is like making it a lot smaller. So if you want to hit them with gigabytes of pickup files, you want to replace it with zeros or with random bytes. Yeah, so that's why this feature is in. You can see it's made for presenters in a lot of ways. You can also replace it with a pattern. For example, payload removed by Tracewrangler. Or you can write in there like, Jasper was here. Stuff like this, okay? Or even better, SharkFest 2018 for the win. What you can also do is you can tell Tracewrangler to truncate after a certain layer. So for example, if you know that you only need like IP or Ethernet or something, like this Ethernet encrypted stuff, and you don't need the crypto bytes even, then you can tell it to do that. The interesting thing here is if you know editcap can do the same thing, you can tell editcap, which is a command line tool coming with Wireshark, to cut it at a specific offset, like cut all the packets at 64. Problem is you never know how your protocols are. So this feature here cuts it after parsing and finding out where the protocol exactly ends. So if you tell it to cut it after TCP, it will find out for each packet how long the TCP header is, and then cut the first byte after it. Not just anywhere, but exactly where it needs to cut it. Yeah, because I was so annoyed by PCAP files that had cut as a specific offset and taking away interesting bytes, because that is not really helpful. So you can do it like that. You can also, as you see, combine these. So you could make Tracewrangler replace all the payload and then cut it at an offset, which doesn't make much sense, but it's possible. Or after a layer. And there's one option here that if you don't remove all the unknown stuff, and that is a prerequisite that you uncheck this one, you can replace strings anywhere in the packet. So I could go in there and say, well, if you find something like, come on, Bongertz, which is my last name, replace it with Landström, which is Christian's name, and it will calculate a delta for you. Now, you want the delta to be 0, because if it's not, what will happen? The payload, pardon? The payload will be longer or shorter. And what do you think will happen if you open the trace file in Wireshark? It will go completely nuts, because the sequence numbers don't match anymore. Your payloads are longer than the sequence numbers indicate, so it will tell you have packet loss, loop arc, whatever. So normally, this is not allowed. So if you do it like this, it will still work. I could keep it that way, but it will cut away the two characters at the end. So Bongertz will be replaced with Landstro without the ENM. If you are fine with replacing longer and shorter stuff, you could say, do not enforce the same length on replacement, but then your sequence number will jump out of the window. So they will go completely crazy, or Wireshark will. So let's do it that way. I don't know if it will happen in this trace anyway. So the next thing is picabenjy. Who knows what the picabenjy standard is? Nobody. Do you know that picabenjy is the file format that Wireshark uses by default? Who knows that? Okay, the rest of you just learned something new. Yeah, so picabenjy is the file format. The interesting thing about picabenjy is it keeps a lot of additional stuff in the file format that pcap doesn't have, including interface names. So you can have a trace file that tells you, hey, this was captured on ETH0, ETH1, or a GUID on Windows. This is like an additional information that you won't see in Wireshark if you open the trace file, but it needs to be replaceable. Because sometimes you don't want to know want somebody to know that you captured this on this specific machine. Because the GUID on Windows is 100% re-identifiable if you want to. So it can do that on the picabenjy stuff as well, also with filter strings, if you want to remove the filter string, stuff like that. And then something new that I added recently was 802.11. So you can even now change SSIDs for VLAN access points. The interesting thing was that, of course, as soon as I did this one, people came to me and said, well, I got this crazy VLAN option here. There's some vendor ID in there. Can you replace that one as well? Yes, in the future somewhere, because it means that I need to program this, because otherwise it will be considered unknown stuff and be removed. So I'm working on it. Then we have Ethernet. That is quite simple. It allows you to replace addresses by a list. So if you want to remove a specific MAC address and replace it with another specific MAC address, you can just add it here. Same as for IP addresses. And I will show that for IP addresses. Then we have something very interesting, that is recalculate the checksum. Because if you're modifying a packet, the checksum will not match anymore. So you will have broken checksums everywhere. Now, the typical first thing that comes to mind is, hey, then just fix it. But what happens if the checksum was broken and you're fixing it in the anonymized version? Then you made something that was bad into something that is now looking good. And the guy looking at the trace is like, hey, this is fine, even though it was not fine in the beginning. So you can set here that it should replace the checksum and make it good under any circumstance, or keep bad checksums bad, and that is the default. And that was a funny challenge as well. I think I've told the story before. How do we make a checksum bad? Well, the first idea was set it to a random value. Yeah, but what happens if the random value by chance is the correct value? You can't do that. Exactly, that's what I did. I calculate the correct one and I add one. So if you see a CRC that is off by 1, very often that means it was sanitized. I had some crazy people from CrowdStrike. I've got friends in CrowdStrike, and they said, well, you could do a calculation like calculate the correct checksum, and if it's bad, get the distance, how much it's bad, create the new one, and apply the same distance. And I was like, yeah, if I have enough time, or if I don't know what to do with myself, then maybe I will add this. But right now, it's just like that. It calculates the correct one, adds one, and then it's done. OK. VLAN. VLAN, sometimes you want to remove them. So there's a number of options to do that. Tunneling. There's something called AIA, or whatever you would pronounce it. It was used by Success, which was an IPv6 tunneling company, which have stopped their business. So having that in there is legacy now, because nobody has packets like this anymore. But there's MPLS as well, so you can randomize the label values if you want to. And that was one of the changes where I think in Pittsburgh, Sake came to me the evening before his presentation and said, hey, can you change this in this way? And I was like, I'll try. And I think I made it, right? Did I? Did it work? Yeah. I think it worked. Yeah, so sometimes if I can do it, it wasn't that big of a change, but it was like, hey, yeah, I tried to. So now IPv4, and that is one of the most interesting config dialogues in this whole thing. Because you can see we have replace addresses by list, replace addresses by subnet, and randomize. So this is a staged approach. So if you want to replace IP addresses with something specific, that always is the first thing that is checked. Do I have a specific rule to replace a specific IP address with something else? If yes, that will be done. And as you can see here, there's already something in there. You can see the 192.168.124.100, my private IP address, will be replaced with 192.168.0.1. And the server address will be replaced with 10.10.10.1. I call this the Hansang option, because that's what he likes. He wants to have this clearly identified two different IP addresses. Once again, this looks easy, but there's a lot of logic behind this, because what happens if your two IP addresses are in the same subnet? Let's say I have a trace where 192.168.124.100 is talking to 192.168.124.200. Then I can't do this, because they're not in the same subnet. And everybody knows that, because this is so much far apart, doesn't make any kind of sense. So what Tracewrangler does, and it only does that if the auto mode checkbox is set, it will check how many hops are they apart, the two. It does that by looking at the TTL, and it says, okay, this one got TTL 128. A typical starting TTL is 128, so the hop distance for that one is 0. It looks at the other one and says, oh, this is 64. Typical start TTL for Linux is 64, so it's both 0. They have a difference of 0. They're in the same subnet. Then it will do a replacement with 192.168.0.1 and 0.2, so that they stay together. Because otherwise, you're sending this trace to somebody, and he says, why do you have a hop distance of 0, but total separate IP addresses? I think that is your problem. And it's not. It's just a sanitization problem. So this is what happens in the background, and you don't see it. And this is why it's so slow doing these things, because you have to consider so many things that nobody ever thinks about. And that's what I did in this place. So the next thing is, and it only does that, by the way, if there's 2 IP addresses in the trace. If there's 3 IP addresses, I can't do that anymore, because then it gets confusing. So very often, trainers, presenters, they have one conversation that they want to show. And if you filter that down in Wireshark and then put it in Tracewrangling, it will do that automatically for you, like this. OK, if you have no rules like this, or you have something else, you can replace them by subnet. And you do it in slash notation and just say replace 192.168.124 something. For example, 192.168.124.0.24. You can see I do a lot of input validation. And I can tell you, programming the logic of replacing stuff is a piece of cake compared to all the input validation that I need to do, so that people don't input crazy stuff. Let's say we replace that one with 192.168.0.0/25. That shouldn't work. Well, it should be the same mask. So what I did now is, if it finds the 192.168.124.100, it will be replaced with 192.168.0.1. If it finds any other IP in that same subnet, it will become 192.168.0. And it says keep host part, so the host octet will be kept. You can also set it to randomize if you want to, but very often it's interesting to keep the same IPs together. Yeah? You only want to change the subnets, and nobody should know that you're running a 10.whatever subnet, but you're fine with the IP IDs or the IPs of the host to be the same. And then if that doesn't work, there's the remaining processing that says randomize or black marker. Black marker is something that the early version didn't have. Black marker means 0 bytes written over the IP address. I only added that because packet anonymization is one of the most used ideas for academic papers ever, I think. If you're looking for academic papers on PCAP anonymization, there's like a ton of them. And there was one that said, yeah, we looked at a lot of tools, and Tracewrangler was among them, but it got a worse rating because it didn't have black marker, because it wasn't able to 0 addresses. So I was like, OK, that's an easy fix. That's why I added it. I never use it, but it's in there to get a better rating on the next academic paper. Okay, so then there's another thing. You don't want to randomize multicast addresses because they're special, and you need to keep them special. So normally this shouldn't be checked. Same with APIPA. Who knows what APIPA is? It's when you do DHCP and you don't get an IP address and you end up with 169.254 or whatever that range is. That is a problem in itself. It's not exposing anything except that your DHCP doesn't work. So keep them. And the last one is documentation. What's a documentation IP address? Well, the IPv6 people, they're like, yeah, that is 2001 DB8 something. But few of them know that there's also one for IPv4. I can't remember the range because who uses it? Nobody does, but there is one. And if it finds it, it will keep it. Unless you check it, then it will be randomized. And the other thing is private ranges. Very often private ranges, since they are private ranges and you cannot tell where exactly it is, it makes no sense to replace them. But to be sure, I keep it in a setting that says randomize into another private range. So it will end up in a private range again, but just not the one that is already there. And once again, if you do any of this, what you need to make sure is that by no coincidence, you end up with the same IP address replacing the original IP address, because then it doesn't work again. So there's a lot of checks in the background looking for the IP address that is the original, creating a replacement by this rule set, and then checking, hey, is it the same like the one I'm replacing right now? And if it is, start from the top and do it again until you get one that is different. Then both get written to the database, so as soon as I pull the same original IP again, it will be replaced with the same replacement. And that works for all the other things as well. Okay, so the rest is like very easy. There was a suggestion by German law enforcement that says we want to remove some specific ICMP messages. Most often, I think the thing is communication administratively prohibited by filtering. So that seems to be one ICMP message they want to remove. Or destination network administratively prohibited is another one. So you can do that. ICMP v6 is a bit more complicated and has less options because I didn't have time for them. But ICMP v6 is a very important protocol because it also replaces ARP. And there's a lot of things happening in there. So if I see an ICMP v6 packet, it could be a router advertisement, neighbor advertisement, whatever, and there's always IP addresses in them. But you don't see an option for replacing them here. And the reason is because that is done on this layer. Because very often people look at the anonymization and say, hey, where's ARP? Why don't you have an ARP tab? That's because in an ARP protocol layer, you have MAC addresses. Look at the Ethernet thing, it's in there. And IP addresses, just do the IPv4 thing. So all the settings here will not work just on that layer that is labeled there, but it will work on all the layers that Tracewrangling understands. Okay, so let's say we have enough. We can do TCP stuff, replacing ports. Somebody wanted me to be able to replace by socket list, so that you can say, I want to replace a specific IP within a specific port with another specific IP in another specific port. And that's possible now. So you can do that if you want to. I forgot why he wanted to do that. Sometimes people use that kind of feature to change traces they have to be able to replay them. So that's in there now. And then we have stuff like DHCP. FQDNs in DHCP can be removed. The next protocol that I probably need to implement is DNS. And DNS is a nightmare. Because DNS, I can parse DNS now. That works, but I cannot reassemble it yet. Because DNS uses compression and other crazy stuff. So you have pointers in the DNS payload telling you like, hey, this FQDN is constructed by looking here and there and this byte and that byte. And putting that back together is really complicated. So I haven't done it yet. So in this case, this one will only replace them with X's. So if you have an FQDN, it will be xxx.xxxxxx.xxx, whatever. Okay? All right, and then there's one application protocol that is called RTPS. Who's heard of RTPS? That's like an industrial protocol. And 2 years ago, I was having surgery, and I was at home because I couldn't work. So this guy, he hit the Wireshark developer mailing list and said, hey, I've got this UDP-based protocol. Can you help me sanitize that one? And I don't know who of the co-developers it was, but they were pointing them to me, like, hey, this guy is writing Tracewrangling, maybe he can do something for you. And I made a mistake. Because I said, UDP is simple. Because UDP is one packet only, so I can sanitize that packet and write it back out, easy. Because TCP is really complex. You get TCP packets, you need to reassemble the payload, and that can be really complicated. So I said, UDP, I got this, easy. So I built the stuff for him, and it's a hugely complex protocol. So what I did is I found the things that need to be replaced, and I copied the rest that is not critical. It's like a cheating kind of thing because it breaks with the don't keep stuff that you don't understand rule, but I was following his guidance. He told me what needs to be replaced and what not. And I got it done, and I sent it to him, and I was like, here, done. It only took me like 4 days. And he kept running tests. And then the bug reports came in. And guess what? I had forgotten about IP fragmentation. Because they have IP fragmentation like crazy, which means that you need to reassemble all the IP fragments, put them together, and then sanitize the UDP payload. So I needed to write in fragmentation reassembly thing. And that is complicated too, because you cannot just get all the UDP fragments, put them together, and do something with them, but you need to keep them in a way that when you write them back into the trace file, that they end up in the same order that they arrived, but with replaced values. So you need to put them together. You need to remember where the cut marks are. You need to replace the stuff, then cut them into the same chunks again. And if there's interleaved packets between them, you need to write them in that order. And that was like 4 weeks, I think, instead of 4 days. So yeah, I know what will be ahead of me if I ever try to do replacement in TCP, because that is much worse. TCP payload replacements are like insanely complex. This is why it's not in there yet. Okay, so output, you can output the file into the same directory or into another one, and there's a output option that allows you to generate a file name. Usually it stays just like this. And since I'm done with this one, let's just run this one. Run. So you can see here we now got a HTTP sample underscore anon. That is the anonymized version of what we just had. It has a date of 26th of June at 2 o'clock in the morning, which is German time. So this is my trace now. And I did something wrong because there's still the payload in there. What did I do? Did I remove the checkbox? Yes. So that's a good example. I replaced all the stuff. You can see that the IP addresses are changed, right? Excuse me. But the payload is still in there. That's because I unchecked the remove the unknown stuff payload thing. So you should never do that, unless you're presenting, maybe. Okay. Just run it again, change it, run it again, and open it again. And now we can see payload is gone. Right? No more HTTP, whatever. And I think the GET packet was the 4th with a push flag. It had a size of 552 bytes. And where's my packet pane? I think it's here. You can see it ends with TCP, and there's nothing behind TCP. Because right now I can parse HTTP, but I cannot reassemble it for obvious reason, because TCP reassembly needs to be done first. So it's gone. Okay, let's see. I should have replaced it with a pattern. Let's see, is there a pattern? Ah yeah, there's the pattern. So it didn't cut it away, it replaced it with Wireshark for the win, so very easy. Okay? So the idea for this kind of task is that the preset are good enough for a newbie to put a pcap in there, run it, and end up with something that is still useful but completely non-critical. Now that's the idea. So sometimes I'm tweaking a couple of settings. For example, I was randomizing the IP ID in early versions because sometimes the IP ID is a thing that you can use to track activities of a host. But then it turned out when people were sanitizing their pcaps, randomizing the IP ID makes it harder for us analysts to tell if this is a real retransmission or not because we need to see the IP ID. And that's why I turned it off, because I said, this is not so critical that we need to have it replaced in any, always. So I changed it to, well, keep it, but the option is still there, so you could replace it if you wanted to. All right, so as you can tell, I can talk about anonymization like for days, because right now it looks like I'm the only one who's writing a tool like this and keep building it. Because I told you about the academic papers, what they all do is they build a tool, right? And as soon as they turn in the paper, what happens? They get a grade, or whatever they get for it, and then the project is like, done. So you can find a lot of anonymization tools out there that are discontinued for years now, and I try to keep this one alive, because there's always something new that you need to do. Okay, so that was that one. Are you still alive? Who's asleep now? Okay, I should ask who's awake, because a question like this is stupid. Okay, so wake up. Editing. Unwanted layers. As I already said, you can remove VLAN tags, GRE headers, GTBU headers, MPLS shims, and also CAPWAP. That was a very interesting thing. CAPWAP is like a transport protocol that you use for wireless traffic. And I was at the customer side, and we were discussing implementing IDS IPS systems, because I'm cybersecurity, so network analysis is only something that I do on the side sometimes. And this customer, he was talking to me about CAPWAP, and he said, well, it's encrypted, so it's no problem. I'm like, no, it's not encrypted. And he says, yeah, it's encrypted. I'm like, no, it's not encrypted. I can tell you for sure, because I wrote a dissector for it. And that was the moment where he was like, okay, you know what you're doing. Yeah. CAPWAP is really interesting, because then you can pull the traffic that is running on top of CAPWAP, and you have a lot of tools that don't know what CAPWAP is. Just remove all the stuff, and what it will do, it will give you the Ethernet or whatever it's transported on top of it without the preceding headers. And then you can run it through any analyzer tool that you have. So usually all the edit features are because somebody walked up to me and said, I got this crazy trace, can you remove the stuff for me? And then I need to figure out how to do that, because replacing or editing stuff in a pcap file, which you sometimes can do with reorder cap and edit cap as well. The problem part is, if you, for example, you can see here, this is a double VLAN tag. Two VLAN tags within each other and or following each other, and then it's an ARP packet, 806. So what happens if I cut away the VLAN bytes, which would be 4 bytes each? I just cut them away. What happens? The frame breaks. Because Ethernet will tell me, hey, the following thing after this one will be 8,100 hexadecimal, or hex 8100. But in fact, it's 0806. So what Tracewrangler does, it reads the last type down here and moves it up there. So mending the layers again. So it will look like this. And it does that for all the protocols that you can remove. It will always find what is the next protocol that needs to follow and then move it up so that it keeps working. Okay, yeah.
Quick question. So you can do the, you can remove, when you say remove VLAN tags, you can remove like the QBQ, you can remove the two of them, and you can remove multiples.
Yeah, there's actually 2 options to do that kind of thing. And we have Simon to thank for that. Is Simon here? He's not here? Okay. what you can do is, first of all, the question was about how can you remove VLAN tags? Is there a specific range that you can remove and stuff like this, or do you always have to remove any of those, right?
I was happy that you can remove, like if you have 2 VLAN tags in there,
Yeah.
or if you have 2 MPLS headers, you can remove.
Yeah, I think I have a trace like this somewhere. No, not here. I was having something somewhere. I can't find it right now. But there's 2 options actually. I'm just adding one of them. Let's use this one, just so that I have something to show. You can use the edit task to remove VLAN tags, which will remove all of them, no matter what they are. So they will just disappear. If you want to have more control and you're saying, I need to keep VLAN 100, but I want to remove VLAN 12 to 200, that would be done with an anonymization task, because in there, you can say exactly what you want to replace, by list or by a range or much more complex. And the reason why I put it into an edit task is because Simon came to me and says, can't you edit VLAN tags? It's really simple. And I was there, yeah, but it's in the anonymization task. And it was like, oh, I didn't expect it over there. So I added to the edit task as well, but just the all or nothing option. So if you need more control, do the anonymization. All right, so edit files. Let's take a look. You can do something on the packet list. For example, reorder packets by absolute time. What is that good for? Has anybody ever seen packets that were not in order? Yeah? When does that happen? If you capture on more than one interface. There's an interesting thing happening if you capture on more than one interface, because if you have 2 network cards where packets come in, and you have a dump cap process running on top of these 2 cards, grabbing packets from them, it's not like that they always are grabbed in the order that they arrived. Very often you get negative delta times, because one packet arrives, it gets grabbed. Another packet arrives here, but it doesn't get grabbed. Then the next arrives here, it gets grabbed, so you have 2 on this side, but this one should have been between them, but it ends up after them. The good thing is, the one ending after them has an absolute timestamp that will tell you it belongs to the place before the 3rd packet. And with this, you can reorder that. This is not so important anymore, because there's also something in the Wireshark toolset that is called reorder cap, which does the exact same thing. It reads the whole trace, orders the packets by timestamp, and writes them back out. So if you're capturing on more than one interface, you always need to run this, because otherwise your packets will be like mangled in the time order, and your TCP expert will jump out of the window again. Hansang.
The Tracewrangling one, can you go back to that screen?
Yeah.
So here with the absolute reorder by absolute.
Yeah. The timestamping is done before it's pulled into the PCAP file.
Can you adjust it by 2 seconds? Or 2 milliseconds? So if you capture a multi-home server,
Yeah.
or into 2 different switches,
Uh-huh.
and you're doing a request and reply here,
Mhm.
if you span that, there's more serialization to the span port of the reply. It's 20 small requests, big chunks of downloads.
Yeah, right now you cannot do that kind of thing, but if you have a specific case, give me the trace file and I will see what I can do. The problem always is that this kind of problem is interesting, but as long as I don't have a PCAP for it, it's hard to implement the fix for it. So if it ever occurs, let me know. So basically all the edit options are because somebody sent me a PCAP file. Fixed frame size metadata, we sometimes get broken PCAP files where the frames are shorter than the length indicates. and then again it breaks. So with this, you can pat them so that they are good again. So this is like a picabenjy or picap repair tool. Usually you don't need it, but if you need it, you will find this really useful. And there's a sub-option to, if somebody uses hard slicing. Hard slicing is what I call if somebody says, give me only the 64 bytes of the frame, which is a quite common thing. But in most situations, the frame will tell you, but the original was this long, not that long. This is what you got in bytes, but it was this long. And there's some capture tools that will tell you, this is the frame this long. By the way, it was originally also this long, which isn't true. And with this option, you can repad it to the correct size. And Tracewrangling does that by looking at the IP header, where the length field tells me how long it really was, and readjust the meta information of the frame to make it as long as it should be again. This is, again, some esoteric magic that few people ever need, but it was interesting, so I put it in there. OK, Linux cooked headers. Who had ever have Linux cooked header traces? Nobody? Really? If you're capturing on Linux on the all or any interface, what happens? You get a trace file that doesn't have an Ethernet header. It has a Linux cooked pseudo header. And very often tools can read that one. With this, you can replace it with a fake Ethernet header, so it looks like a normal Ethernet trace again. And then you can also set the MAC address. You can replace the ether type if you want to. So these are all options that somebody wanted from me. Then there's the Juniper thing. You can remove the VLAN tags, all the other things. So basically, the idea here is to give you the Ethernet protocol that was transported over something else so that any tool that is capable of working with Ethernet traces can read it. That's the main idea here. OK. And then we had something interesting, picabenjy meta. We had a question on ask.wireshark.org where somebody was merging pcap files. And I don't know what he was doing, but he was saying he merges pcap files, and they're from different capture locations. But he wants to merge them all together, which in my mind is not a very good idea. You should keep them separate because they're from separate locations. But he says he wants to merge them together. But he wants to be able to tell on which interface they were captured. And if, in his case, all his interfaces were called ETH0. So you couldn't tell after merging where they were captured. So he wrote a script that would put a comment in each packet telling you which interface it was captured on. But if you're reading a pcap to put a comment to each packet, that takes forever. So his idea was, hey, maybe we could replace the interface name in the merged file with the original location name, so to speak. So this is what I put in. With this one, you can just modify the interface name in the picabenjy header and set it to a specific value. So you add all the files from one location, put a name in there, modify them, do that with the second set, then merge them together, and you can tell from the interface name where they were captured. It's a very rare case, I think, but if I have the time, I put stuff like this in. So if you have a problem that is really strange, just shoot me an email. And if I got the time and it interests me, it will be ending up in there. All right? So this is probably something nobody ever needs. All right, so I think edit tasks are not that important. How much time do I have left? 20 minutes, I think, right? OK, so I think we should concentrate on extracting stuff, because that's much more interesting. So extracting stuff from big files is something that you want to do in a lot of situations, at least I do. So let's go a bit crazy and run Tracewrangler on, let's say, I don't know, maybe a 10 gig or something. I throw all the files in there. And as you can see, it doesn't scan them anymore because I pre-scanned them before the presentation, but it will read all the settings from the database file, so that is quite fast. So let's see, we have now 40 files in here. Total frames, 15 million. Total bytes, 9 million something. Okay, so this is something where you would probably get Wireshark into trouble, especially since these are 40 files, separate files. So what I can do now is go up to Tools and say, give me the communication details. That's my name for the conversation and endpoint statistic. I put them in one combined dialog, and it looks like this. You have MAC addresses, IP addresses, IPv6 addresses, MAC conversations, IP conversations, IPv6 conversations, TCP conversations, UDP conversations. Just like the endpoint statistics in Wireshark for IPv4, IPv6, and Ethernet, and the same thing for conversations. Now, the interesting thing here is that, for example, if you look at IPv4 conversations, I added a couple of things that Wireshark doesn't have yet. For example, the average round trip time. So Tracewrangling will look at all the conversations between an IP and will give you an average round trip time over all of them. So sometimes you have no handshake for one, but maybe you have another conversation between two of them, then it can pull that value from the other thing. And usually it's quite close to each other. The initial round trip time doesn't change that much between takes. It will also tell you how many flows there are. In this case, 16, 31, 24. It will tell you if it spans multiple files, which means that it starts in one file and ends in another. I had a hint, a mouse over hint once, where it tells you exactly in which files that is, but usually it gets like really big and you don't see anything anymore. So that is something that I added here. And the bug that I fixed 3 days ago was that you could say, well, these 8 flows here are interesting. What are they? And you can double-click them, this line, like this. And down here, you will see it starts extracting frames. And it's done already. I think it takes longer to start Wireshark than to carve that stuff out of there. And here are the conversations. Yeah, the bug that I fixed was that my filtering didn't work correctly, and I ended up with empty PCAP files. The latest version works again. So let's check. This is now a demo can go wrong mode, because now let's check how many conversations are in there. There are 8 TCP conversations. Yay, so it worked. Because sometimes you end up with something where Wireshark says, no, you only have like 4, because there's still a bug somewhere. But this is how it works. So if you want to see anything between 2 IPs, it's just a simple double click on that, and you get them. Then there's another thing that I added to UDP, I think. It has the typical packets, bytes in one direction into the other, so you can sort it by anything if you want to. And then I have, where is it? Packets per second from A to B and packets per second from B to A, because we had a problem with our WebEx setup. And somebody told me there is a voice protocol that has 3,000 packets per second. Like constantly, every 20 microseconds or milliseconds or whatever it is, there's 3,000 of them if everything works fine. So I decided just to have a counter in there saying how many packets per second do you have, because if the voice quality goes down, you could tell the calls that were not working correctly had a non-3,000 packets per byte value. So it was a very simple thing to put in there, but it's only useful for this kind of voice stuff. So if you don't need it, you can always click here and say, well, I don't care about this one, and about, no, megabits is the other thing, this one, and this one, and you can remove the columns. Right now, I don't store that setting, but it will do that in the future. Now, the most important thing probably is TCP conversations. Once again, I have the initial round trip time, so you can do interesting stuff like, hey, sort by initial round trip time. And you can see here, there's a conversation that has an initial round trip time. So TCP handshake took 81 seconds. That is interesting, right? And the reason I put that in was I was at a customer site where they said, hey, can you capture for a week and tell us if you see any problems? And that is like, right? Because you have no indicator of whatever. They're just telling you, like, find something with your experience. And then they're like, okay, my report is going to be very empty because what are the chances? Because I had like, I don't know, 500 gigabytes of traces in the end. But I used Tracewrangler to give me pointers like this. So I started looking through all the things where, for example, I saw that, let's say the round trip time is this high. Double click it, it will extract it. And keep in mind, this is 10 gigabytes. It's pulling a single conversation from. So it knows from the database, oh, this one starts in the 7th file. It's complete by this 9th file, so I don't need to read the rest. So this is why it's so fast, pulling stuff out of there. So now let's see. Let's make this bigger. And as you can tell, the handshake is syn, synac, 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 egg, push egg. I don't know where it's complete, but let's see. Where's my relative time? Where's my time? Too many numbers here. Source destination protocol, where is it? It's here. There's 41 seconds before this one is complete. So yeah, this does look bad. All right. So if you have something like this, this is worth investigating. I think in this point you can look at the geo-IP, and it will tell you this is a Telefonica Germany conversation coming from a Telefonica IP. And you can bet on this was a handheld device in a bad roaming area somewhere where it has bad reception, and then this happens. Now this is why I always recommend having geo-IP information in Wireshark, because it will tell you a lot about the problem. If you see an initial round-trip time or a handshake like this, and you can tell from the geo-IP information that this guy on this end was in a very bad location, then you may be able to just say, hey, I don't care about this one. There's nothing I need to investigate because this is just bad. Okay, so other things that I put in there is packet ratio. You can sort by one-sided conversations and look for things where, okay, scrolling is stupid. You get stuff like 100% to 0%, so it's a one-sided conversation. Sometimes this is interesting because you can tell that there's only one side of the conversation, and then you can investigate. Okay, and then I have something else that is called status. It will tell you if it has seen a full handshake or only a SYN or a half open, or if there's a reset. The problem with that thing here, it is really complicated to do the matching because you need to look at a lot of packets and correlate them. And this works okay-ish, but not perfect. And one of the reasons why I have another talk, I think tomorrow, about writing a TCP analysis expert is because I wanted to better than this. And you will see in that talk how I did it better than this. But this is just there to give you an idea of where things may be broken. Let's see if we can find anything interesting here. Yeah.
To see this, you just went to your picabenjy and then just said tools and communication details, right?
Yeah. Exactly. But you need to have scanned the file before, otherwise nothing will show up. The interesting thing here is, and it's I blame Christian for it. There's a setting in tools. Options, preferences, and you can see here auto-scan. Usually there's 50 megabytes, so it won't scan anything that is bigger than 50 megabytes because I don't want to steal your time unless you want to. Put it to 0 and it will scan anything. Yeah, and I blame Christian because he told me don't put 0 in there, puts 50 in there because people don't want you to put 0 in there. But I always get the question, why don't I see anything? Because the scanning didn't work. So just scan it, and then you'll be fine, I hope. If not, we'll do a bug report. OK, so I had this one here, SYN rejected, I think. Where was it? SYN rejected means there's a SYN reset. Yeah. As I told you, you get a trace, and you're supposed to be telling about problems without any indicator. It's like, this is an easy one. Because you can find misconfiguration really quick if you do that. Where's my Wireshark? Why hasn't it started yet? There it is. Yeah, so this one is a problem because it should diagnose SYN reset, but it diagnoses SYN reset. It's still a problem. It doesn't look so good, but that's a little bit of a thing where the analysis is a little bit off, which is why I wrote the other analyzer. So with stuff like this, you can really quickly work on a big set of files and look at conversations without having to open them all one by one in Wireshark. OK? You could also extract more than one conversation. So if you're saying, hey, I need this set, just do that, mark them all, right mouse click, and then extract to a single file containing all the rows, or if you want to, one per conversation. OK? Then I have something that is called, I don't know, view aggregated mode. In that mode, it will pull all the IP address pairs and group the TCP sessions underneath it, like this. Can you see? Here's now all the IPs. Can I collapse them? No, apparently not. But here you can group the TCP connections under the IP pairs. So that is another helpful tool sometimes. And then there's a crazy option again that is called toggle highlight mode. And toggle highlight mode is when you do packet matching. What it does is, let's deactivate the other mode. Do I have time any? Yeah, I still have 8 minutes. Are you still awake? Who's asleep? All of them? OK. Toggle off aggregated mode. Now we need to wait a little bit. And now activate highlight mode. And that is an interesting thing because it only works in some situations. The one conversation that you select here, you can see it changes if I select different things. Highlight mode does the following thing. You select a conversation, and all other conversations that end after the one you selected, end before the one you selected, and started after the one you selected will still be shown. So sometimes you want to do something like, hey, I have this conversation that takes a long time with nothing happening in this amount of time. Show me all the conversations that start after this thing stops here and ends before it continues. And that's what this one does. It will basically tell you all the conversations that are embraced within the one you selected. Yeah, it's a little bit crazy, but we needed this for one analysis where we were tracking down an error with the proxy. So we needed to know if we send something to the proxy, we need to see all the conversation that the proxy initiates and ends before we get our result back. So that's highlight mode. Yeah, that's the cool thing. If you're programming your own tool, you can put in stuff like this where all the Wireshark developers are like, no, we don't have time for this kind of thing. So that's highlight mode. Turn it off again. OK, that's enough here. Then one final thing I want to show, if I have time, 5 minutes, yeah, is something that I've shown before, and that is extracting snort hits. So Tracewrangler can help you with snort hits. The problem, who has used snort before or any kind of IDS IPS? Hands up, please. I have used it forever. The common problem, and everybody is groaning about this kind of thing, if you get a hit in an IDS, what do you get? The one packet where the hit was. And you're like, well, I need context. I need to see what happened before the hit. I need to know what happened afterwards. Please give me everything. And usually, you won't have it. So if you look at a snort result, for example, I ran snort on this file set, snort.log, snort capture 01, 02, 03, and you can see these are the big files that I captured, and these are the result files that contain only the hits, and we can take a look at them. Let's use this Wireshark instance, for example. So you get one packet per hit. And for example, you have this 403 forbidden. So what is the problem with the 403 forbidden? You don't know what the calling URL was, because you only get the hit on, hey, this 403 looks funny. This is the packet where the 403 is in, but you're like, hey, I need the GET request. Give me the GET request. So I needed the GET request, and what I do with Tracewrangler is I can use the alert file. This is this one. Let's open Notepad for it, because it has a bigger font. The alert file of Snort looks like this. This is the old format. There's a new format, Unified 2. That is a binary format that will also work with Tracewrangler, but this is the normal one. It will tell you what it found. So what you can do now is you take all your original full-size PCAPs, all of them. It's 3 only, and I've done that with hundreds of them. Put them in here. So it knows all of them. Now I put a extract from files task in there, and I tell it to import the pointers from a file. And I use the alert file, like this. It detects automatically that this is a Snort alert file. Okay. And it builds a filter list to pull all the conversations from those 3 files that had a hit. All right? So, and it also has a filter label that tells you what the Snort hit was. So in the output thing, I can now say, well, extract them to files and use the filter name as a subdirectory. So what this will do is it will go through the 3 files, find all the packets that belong to a conversation that had a hit, and write them into a subdirectory with the name of the rule that matched, and the file name itself will be source IP, source port, destination IP, destination port. Okay, let's see if that works. I go here. So if I run this, there should appear a new extracted directory. There it is. And I did something wrong because it just puts the files in there. Yeah, that wasn't the plan. I configured something wrong, but you can see it extracts all the conversations. And now I can basically open Wireshark on any of them and quickly check them. And my recommendation is open one Wireshark instance, because you can tell it takes quite some time to load it. Open one and then drag and drop them one after the other. And if I check IDS hits, I only have the directory open on one monitor, and I drag and drop them all one after the other onto my Wireshark, and I check the results. So here you can see there was a hit because it's colored green, because there's a packet comment, and I write into the packet the hit of the Snort rule, so that you know, oh, this one was a Snort hit, and this is the packet where it hit. Okay, so with this, you can quickly open all the hit conversations one after the other and do a false positive evaluation and say, this one I don't care, this one I don't care, this one I don't care, because let's be honest, what's the ratio of false positives in an IDS scan? It's something above 95% at least, if not more. I would say it's probably 98%. And if you need to verify stuff like this, it can take forever. I've done that by hand manually once for a week, verifying a couple of hundred conversations. Now I do it with this, and I'm done within the hour. So this is another thing that I added to help me get through some tasks that basically make me repeat stuff. And this is much easier. I think I need to come closer because I don't understand anything from there. Yeah. No, if you have multiple hits in a conversation, you will end up with one conversation, depending on what you use as an output pattern, because the output pattern will look at the IP and port, and if it matches something that it has already written, it will just append the packets to it. Okay? So the question was, I know, I'm up for time. The question was, if you have multiple hits in a conversation, will you have multiple files in the end? No, you won't. You will have one with all the hits in there. Okay, so I'm 2 minutes over. I hope maybe you see what Tracewrangling can be used for. This is like something where I add functionality all the time, very often because people want to do something. If you have anything where you need help with and you don't want to do it by hand and I can write something for you, just let me know, give me a PCAP. The funny thing about anonymization very often is like, hey, I need you to anonymize this. By the way, I can't give you the PCAP because it is critical. And I'm like, yeah, all right. Bug fixing is problematic too in that way. So I hope you can use it, and thank you.